Hello. My name is Oleg Ninashev, and today we talk about Gradle Build Tool 8.7. This is a release we shipped in the end of March. Today we asked contributors to share some demos for key features we have in this release. We will talk about support for building Java 22 projects and Groovy compilation and build cache. As always, we have a lot of improvements for build authors, including beta error propagation and warnings. We will also talk about configuration cache, new features there, and better documentation that we keep improving with each release. First of all, I would like to thank all the contributors who participated in this release, who submitted features, issues, and feedback. We get more and more contributions with each release, not just to the Gradle Build Tool core, but also to all the plugins, documentation, and the whole ecosystem. Thanks everyone who participates there. For Gradle 8.7, you can already find all the documentation on our website. We have release notes, which provides a lot of information and upgrade guidelines for all the features we discussed today. We also have public roadmap that includes initiatives we are working on, for example, declarative Gradle or configuration cache. If you want to know about new releases and plugin updates, follow our newsletter. We have quite a lot of information there. And if you have any questions, join us on the community Slack there. Okay, let's get started. And the first item we would like to discuss today is support for building Java 22 projects. Let's go.
Gradle 8.7 now includes support for compiling and testing Java 22 code. This support can be leveraged by using toolchains. Gradle itself can't be run on Java 22 because dependencies such as Groovy and Kotlin lacked proper Java 22 support. In the future, we will resolve this by updating these dependencies, and you will be able to run Gradle on Java 22 and compile your code on Java 22.
The next item for us is support for Groovy script compilation in the build cache.
So Groovy DSL script compilation now uses build cache. Kotlin DSL compilation used build cache already before, and with Gradle 8.7 also Groovy DSL compilation got support for it. So what we actually changed? So here we can see pipelines for Kotlin and Groovy compilation, and main steps here are compilation and instrumentation step. And as you can see, Groovy is using some local caching. That's custom caching just used for Groovy, and it's different from what Kotlin uses. And with Gradle 8.7, we unified these two pipelines, so they now look almost the same. And the important bit here is that compilation and instrumentation now go through this execution engine. Now, execution engine is an abstraction of work in Gradle. For example, also tasks use execution engine, and it's important to know that execution engine is backed by build cache. And because Groovy compilation now uses execution engine, that means that also Groovy compilation is now backed by build cache. So yeah, that's the main change. Thanks.
And let's talk about build authoring. We have quite a lot of features there, like better initialization, and also quite a lot of APIs and quality of life improvements that help you to define things easier. So let's get started.
Out of the box, Gradle allows you to generate template projects such as a Kotlin library with a single command. When the build logic is generated, Gradle adds helpful comments to explain why each section is added. However, this is not necessarily desired behavior for advanced users or if you wish to clean up the project before sharing it with others. In Gradle 8.7, we introduce a new option for the init command called no comments, which does exactly what you would expect. It generates the same build logic, but drops all the comments to make the projects clean and nice. If you prefer this behavior over the default one, you can make it persistent by setting build init comments to false in your Gradle user home properties.
Thanks for the presentation. And the next item on our list is collection handling in build definition. So we have quite a few improvements which will be presented by Rafael.
In 8.7, we introduced new methods on the collection properties to make it easier to make incremental updates on collections. The main benefit here is that we now honor conventions. And a secondary benefit is that you have a more lenient handling of empty providers. So list property and set property gained a set of append and append all methods, which are meant as replacement for the existing add and add all methods. And map property gained insert and insert all, which are replacements for put and put all. Next slide, please. A demo here of how conventions are honored. If you use add or add all on a list property, for instance, if you set a convention of a list and you try to add that property, we basically ignore the convention, and the value you get in the end does not contain the value of the convention. With append and append all, we actually honor the convention, so the convention is committed as the explicit value for that property before the update is performed. So you end up with the convention content plus the additions you made. Regarding linear handling of empty providers with add and add all, if you attempt to add an empty provider to a collection property, the entire collection property becomes empty as well. Not empty in contents, but it becomes an empty provider as well. And that surprises people in many cases. So append and append all are more lenient in the sense that if you attempt to append an empty provider, it's basically a low-up and the existing contents are preserved.
Last but not least, we also have improvements for metadata verification file that help you to avoid compromised dependencies by pinning them.
This release includes an improvement to dependency verification. The set of ignored keys in the verification configuration file are now properly sorted whenever Gradle writes the file. This gives all of the dependency verification configuration content consistent ordering, simplifying updates that leverage the regeneration feature. So as we can see here in the example, we've got unsorted ignore keys. The second key starts with a 1, so it should be alphabetically before the first one. If we let Gradle regenerate that file, the end result will be properly sorted.
Thank you, Louis. And let's continue with error propagation and warnings. With each release, we provide more and more features to improve troubleshooting experience for the developers. Now we have better plugin error reporting, copy task analysis, and also ability to suppress dependency validation errors, which are quite popular and quite annoying in some build logs.
Comprehensibility is a current area of focus, and improving Gradle's user experience when a build fails due to variant matching failures during dependency resolution is one way of addressing that concern. These errors can be quite confusing, and troubleshooting them can require a deep understanding of variant selection. One example of this problem arises when running Gradle builds using third-party plugins, when the version of a plugin declared in a build script requires the Gradle API from a higher version of Gradle than is currently being used to run the build. Previously, this would result in a very lengthy and generic error message that many users found confusing. After spending time laying the groundwork and doing internal refactoring in previous Gradle versions, we're now able to address these types of error cases very quickly and effectively, and improve the messaging. This was the first case we selected. The comparison here demonstrates the length of the previous message. It's dense, requires knowledge of variant matching to interpret, and lists unnecessary details about extra variants that would never have matched. What we're able to do now is interpret the failure information we would previously dump to the screen. If the attributes and failure type match a given pattern we understand, in this case a plugin needing a higher version of Gradle to run, Gradle can short-circuit printing this default generic failure message, and instead print a much shorter and more practical message, customized to this particular scenario. Another part of this change is that we not only explain what happened, but also how to fix it. When describing particular variant matching failure scenarios, it's now easy for us to also add new suggestions that will appear at the top of the try list. Here are the suggestions for the previous error. In this case, you either need to upgrade the version of Gradle you're running the build with, or change your build to try using an older version of the plugin, which might be compatible with an older version of Gradle. A request to improve variant matching failure messages such as these has been one of the top voted Gradle issues for over 4 years, so we're very happy to finally be able to improve these kinds of failures. Expect similar improvements to other failure scenarios in the next release. Another small improvement to comprehensibility involves the copy task. The scenario we're addressing here is when a build uses the copy task to extract a file out of a compressed archive, and that file has the same name as another file being copied by the same copy task, with the task set to fail on duplicates. The previous error suggests that there might be a problem with the archive file itself, while the new replacement message completely explains the situation and removes the possibility for misinterpreting it.
And the next demo is about suppressible dependency validation errors. This item is a bit special because we invited Enric Johannes, the author of this change, to present. Enric is one of Gradle fellows, and this is actually what we want to do more in the next releases. If you're a contributor who does a big change, If you want to record a video and publish it as a part of this release presentation, please do that and we would welcome you. Let's go.
Hi, this is Jendrik, and I would like to show you a new option that has been added to Gradle's publishing functionality in 8.7. To demonstrate what this is for, I created a small example, which is a Gradle build to develop a Java library that can be published to a Maven repository. For this, I have applied these two plugins, and I have configured publishing to publish a Java library and to publish to a local folder as a repository. I also created an internal configuration or an internal scope for dependencies, which is a common pattern if you want to declare certain things as dependencies or constraints that are only used internally in a project. For example, a platform to manage your version centrally without publishing the platform itself. I'll get to that later in the demonstration. So let's first add some dependencies here to our library. And for managing the versions of the libraries, I would like to use a platform instead of defining the versions directly. So there are no versions here. And in this example, I'll use the Spring Boot dependencies platform. In a typical setup, you might also have your own platform that is either part of the build or published internally in some company internal repository. So if I've defined the build like this, I can run the publishing and it works. And if I look at what I've published, in particular, it's the metadata, I can see that my dependencies turn up here and that the dependency to the platform has also been published here, including the version of the platform itself. Now, what I would like to do is only publish these dependencies without the platform, which is a pattern if you publish things internally in your internal repositories where you expect users to always use a platform individually and decide on this version of the platform individually. So you don't want to publish this as part of your metadata. We could do this by using this internal configuration and saying now this platform is internal, so it's used when I build this library, but it's not part of what I publish. If we would run the publishing now, Gradle gives us an error. It says something like that the publication doesn't contain any versions or a reference to a platform that provides version. The idea behind this error was, when all this functionality was introduced, that users do not accidentally forget to publish versions, because in earlier Gradle versions it was not even possible to declare dependencies like this without a version. Now, this is useful if you publish to public repositories like Maven Central, where you want your libraries to be self-contained so that users can use them without adding any additional dependencies like the platform dependencies. But as said, in certain scenarios like internal repositories where you are like in a closed world of modules that you version, that you publish constantly, you might say that you always want this platform to be internal and not published as part of your modules. And now what is new in Gradle 8.7 is that it says here you can disable this check here by using this option as part of the suppress validation of the generate metadata task, which is a task that produces this metadata file we have seen before. Now we can do that by either configuring this one task directly or just saying we configure all tasks of the type generate Gradle module metadata. And this task has the suppress validation error, so we can add this new option here. And now if we run the publish again, it works and we can see that we have the metadata now without the dependencies who the platform published and without any version published.
Thank you for the presentation, Hendrik. And now, configuration cache. This feature is still disabled by default, but we hope to make it default in Gradle 9.0. So we keep improving it and we would appreciate your feedback. Let's talk about new features in 8.7.
When you run Gradle with configuration cache, it produces a configuration cache report that, among other things, contains the violations of configuration cache requirements found in the build when you run it. In the report, you can explore not only the actual violation that happened, but sometimes also a stack trace that allows you to pinpoint exactly where the violation happens in the user code. However, in the previous versions of Gradle, it was a bit tricky to find that user code because it could be sometimes further down the stack trace. And in fact, in this case, we cannot see it because it didn't make it on the slide. So in Gradle 8.7, we improved the situation by doing a couple of things. Firstly, we pull out the deepest user code call from the stack trace to the description, so you don't even have to look at the stack trace to find out the line at which the exception happens. So you can already explore that. And in this case, you can see that the first and second violations originate from the same line, so they are most likely the same. In case you do need to look at the stack trace, we now show it in the minimized form, hiding all the internal machinery of Gradle or JDK and bringing the user code to the front line. If you still need to open the internal code, you can do so in the UI or copy the full exception.
And the next update in the configuration cache is support for standard streams, IO or not, that can be used as task property values. So let's see what's new there.
It is sometimes handy to use standard input-output error streams as task parameters, in particular for built-in exec and Java exec tasks. For example, if you're developing a console application that processes the standard input, you may want to consume user input from the terminal when run from the Gradle build. To do that, you need to use system-in as the exec Java exec task standard input argument, similar to what you can see here. Or you may want to pipe the output of an external process into the standard error stream to suppress it later with a shell redirect when running the build. However, prior to Gradle 8.7, only a default configuration of exec Java exec tasks was supported, and it has no redirections. Anything else resulted in a configuration cache problem of not being able to save and restore the input or output stream. Starting with 8.7, configuration cache can now save and restore references to standard streams, not only for the built-in tasks like exec and Java exec, but also for the custom tasks that have these stream references as part of their state. This improvement comes with a few limitations. Only the direct standard stream references are supported, not even the streams that decorate them. So you cannot wrap system out in a buffered output stream, for example. You cannot also use file input stream or byte array output stream. Replacing the standard stream with a system set out, set in, set year, and won't work too. Replacement must happen at configuration time for changes to have effect. However, these changes are not going to be replayed when the configuration phase is skipped because of the configuration cache hit. Replacing this stream is not advised anyway because Gradle already provides customized implementation of streams, and changing them may mess up the output of your build.
Last but not least, Gradle documentation. Thanks to everyone who participates in this effort, and today we have two major improvements. So firstly, Kotlin DSL reference get major updates, and also we have a bunch of sections in the documentation improved. So let's take a look.
In Gradle 8.7, the handling of the scenes tags has been improved by upgrading the Docker version used to generate the Kotlin DSL reference. These scenes tags basically tell you for each piece of documentation, like a class or function or whatever, since what version of Gradle it has been added. And the scenes tags have been present in previous versions of the Kotlin DSL reference too, but only for Kotlin code. And now they are also available for API code, so Java code, which you can navigate to from the Kotlin DSL reference.
In Gradle 8.7, we have fresh new content in the user manual for those that want to write their own tasks or develop their own plugins. Check it out with everything you need in the Authorian Gradle Build section.
Thank you, Joseph and Laura. And basically, this is what we wanted to present today for the Gradle 8.7 release. You can find more on the changelogs, and as I said before, we also have public roadmap with all the initiatives, and we have a newsletter when you can have updates for new releases, etc. Speaking of the roadmap, there are quite a few initiatives being worked on. You might have heard there are new GitHub actions coming out soon. Then there is ongoing work on declarative Gradle. We hope to share a new update. Then in the next versions, we want to show isolated projects. There is ongoing work on stabilizing Gradle configuration cache, providing more features, making plugins compatible. And again, we intend to make it a default in Gradle 9.0. Then we explore options to have a community hub for plugins and integrations, and there is quite a lot of other projects that are being released soon. So, for example, support for running on Java 22 is expected to be shipped in 8.8. Then there is other initiatives like using Java 23, which is already available in preview, providing more features, and of course stabilizing features we already have towards later 8.x releases or 8.9 that is also expected to be available soon. Check out the public roadmap, and we hope that there will be more update there soon. If you have any questions, again, please join us on the community Slack, where we have all the discussions, where we have thousands of people who participate, and where you can find all the information you need. Thanks a lot for listening us, and see you in 1 or 2 months with the next release of Gradle.